Hello friends, welcome to Algorithms. Today in this session, we're going to discuss about sorting algorithms. In my previous session, I've talked about the algorithm analysis, basically the asymptotic analysis or the big O notations, and we also learned about the time complexity, space complexity of different kinds of algorithms. In this session, I'm going to cover few basic sorting algorithms uh, with some theoretical information of them, like how the algorithm is implemented and what are the pros and cons of each of these basic sorting algorithms. And also, I'm going to do a coding session on how to implement these sorting algorithms using Java programming language. So let's get started. So to begin with, we're going to start with Bubblesort. Basically, many of you are already familiar with what is a bubble sort algorithm. If for those who are not familiar with it, we're going to cover some details here. This is basically one of the first sorting algorithms that is taught to students when they're doing any computer science courses in algorithms and data structures. Basically, the idea of bubble sort is to sort an unsorted data, which can be a set of integers or a list of elements, any kind of unsorted data, by doing operations like swapping. Swapping means like exchanging the values between two entities or two elements. So in this algorithm, basically we are going to sort a list of integers which are pretty much unsorted or disordered. So this sorting can be done in both ways, like from ascending order or increasing order, or descending order, which is decreasing order of the value. So if you look at the picture, the bubble sort, uh, in the bubble sort, it's an unsorted list of integers, and the values are being swapped from one integer to the other. And then the swapping continues until all the values are completely sorted in an ascending order. So there are like three kinds of passes we are doing here. In the first pass, we start with the first element and compare it with the next element. And then if the first element is greater than the next element, you're going to swap their values into different indices inside the array. And you continue doing that until the position of this element is placed in the right place or the right position at the right value. So if you see this example, 5 is moved to the second place, then it is moved to the third place because it is greater than 1 and 4. And then it is moved to the third place, which is the right place for 5 to hold with. Similarly, all the elements will be swapped in this way by looking at their positions and comparing it with the next element. So this kind of operation is termed as O of n square operation, which is big O of n square runtime, because for each element in this array, it has to go through it has to get compared with all the elements, remaining elements. So if, let's say if there are n number of elements in this array, for each element, the swapping operation has to be done n number of times. So it's an O of n square, n into n, which is O of n square operation. When it comes to space complexity, we call it O of 1 or constant time because we are not initializing any additional space here. We are just using the existing array to swap all the elements and put them in their right position. So yeah, this is like a very expensive algorithm for sorting, but this is a basic one to start with. So let's jump on to coding or implementing this algorithm. I'm using Java as a programming language to implement this algorithm. So basically, I've created a Java class called sorting.java, where I'm going to implement a method called bubble sort, which will sort an array of elements, unsorted elements. So for those who are already familiar with Java, it should be pretty easy to go. But those who are pretty new to any kind of programming languages like Java or C++, maybe you should go back and do some refresh on the basic things like how loops work, or what are conditional statements, or the basics of the programming language. So I'm not going to cover them here in these sessions. So I can provide you some links towards them in my video at the end of the video, uh, or I can also provide you like how to install this IDE. I'm using JetBrains, which is a simple IDE for Java. So it is straightforward to install your Java, and you create your Java platform for running your programs. So let's start with the implementation. So I'm going to implement this bubble sort. So I have a class called sorting, which I created. So in Java, Java is basically an object-oriented programming language. So the abstract types called classes, and then we have methods, which are going to be executed, and which does the functionality of these kind of sorting or any kind of thing. So let's say we have a method called bubble sort, which returns a sorted list of integers. So I'm just returning an integer array, and my method is bubble sort. And this bubble sort takes an unsorted array. So I will just say my integer array is unsorted, and then what I'm gonna do is, like, first I'll do a basic check if my unsorted array uh, is empty or not. So for that, what we do is we have to check whether this contains any elements or not. So if unsorted array's length is less than or equal to 0, which means if the array is empty or an invalid array kind of thing, I'm gonna just return a new what is called an integer array here. Okay. Yeah. So now what I'm gonna do is I will just pass through the array and create a loop where this is an iterative process to look at all the elements of the array. So the first loop, or the outer loop, consists of the pointer or the index, where you're gonna look through the entire array. You're gonna scan the entire array, and so the first loop goes like this. So the I is the index of the element, and then where I starts from the 0th index, as you already know that array starts from 0th index, and then when I is less than the length of the index, or the length of the array, because the value of I goes from 0 to n minus 1 if n is the length of the array. So I'm just saying I is less than unsorted dot length I plus plus, and the outer loop is the one which does a lot of work for us, like the identifying the elements and then swapping them based on their values. So for j is equals to 0, j is less than unsorted dot length minus 1, j plus plus. So the reason why we are just looking until length minus 1 or n minus 1 element is that because we want to access the the current element in the array, as well as the next element. So when I say, if I say like unsorted dot length, then my j plus 1, the next element, would go out of bounds of the array, and then it throws an exception. So I will just go one element lesser than the maximum size of the array, so that I can access the nth element as well. So I will read up to n minus 1th element, then I can compare it with my nth element. So now if my unsorted of j is greater than unsorted of j plus 1, which is nothing but my current element. If it is greater than the next element, then I would just say, like, there is a temporary element where I'm going to swap the values between jth element and j plus 1th element. So it will be like unsorted of j, and then my unsorted of j will have unsorted of j plus 1, and then my unsorted of j plus 1 equals to 10. So first, what I'm doing here is I'm putting the current element, I'm assigning the current value into temp variable, and then I just copy this temp value, the next value into my current element, and then I'll push this temp value into the next element so that they get exchanged or swapped. So now once this is done, I'm just gonna come out of these loops. Now after all swapping, I will just return my unsorted. Okay. Yeah. So let's go back to our, this is the basic sorting algorithm. So for executing this algorithm, I have already had some, uh, test cases, or we can call them as tests, or, like debugger or debugging or testing this. So what I'm doing here is, first, I'm creating an array called data where I have unsorted list of elements. So I'm just, for convenience sake, I'm just printing it. In Java, we have this method to print the text onto this console. And for each element inside this data, which is like this, I just print them before I sort them. So now I'm creating an instance of my sorting class, which is here. So the class instance is this is called an object or an instance. And then I'm invoking my bubble sort method using this instance, and that returns a resultant array, so which is sorted. So now I'm printing this sorted array. So to print the elements of the array, so I have to go through the loop because I have to fetch each and every element like this and then print them. So let's go and run this. So you have a green button here, just need to run that. So it executes. Okay. So now if you see the output, my unsorted array is 526148, but my sorted array after sorting is 124568. So it got sorted in an ascending order. Yeah. So that's about bubble sort. So in my next video, I'll be covering a few more sorting algorithms. Thanks for watching.